So we're going to be working on solving equations. We're going to go through two types of equations to solve. First one is when your variable has a fraction exponent or a negative exponent on it. So our steps, what you want to do, step one, is isolate the variable. So you want to get that thing entirely on its own. So looking at my example over there to the left, what would we want to do first to get x by itself? Subtract the 3. Divide by 2. So we get x to the 1/2 equals 4. So my variable is isolated. So step 2, you're going to raise both sides of the equal sign to the reciprocal power. So reciprocal means we just do what? Flip it. So my exponent in my example over there is 1/2, so its reciprocal would be 2/1, which is just 2. So we use the reciprocal power because then when I do 1/2 times 2, I get an exponent of 1. So I have x to the first, which is what I want to have. So then 4 squared would give me a 16. So our third step is you simplify if necessary. And you always kind of need to check your answer there. So if I plug 16 back into my original, 16 to the 1/2, remember that means it's the square root of 16, which is 4. So then times the 2 is 8 plus the 3 gives me 11. So it does end up working out. So let's try some more examples. First one, what do we want to do first? Multiply by 3. Times 3 times 3. So y to the 3/2 plus 1 equals 9. Then what do we do with our 1? Subtract it over. So y to the 3/2 equals 8. So what's our reciprocal of 3/2? 2/3. So I'm going to raise both sides to the 2/3. So remember, that's power over root. So 2/3 exponent means it's the third root of 8. And then we square that. So what is the third root of 8? 2 squared is 4. So y equals 4 is our answer. So our second example there, again, get x by itself, so subtract our 5. And I get 2x to the negative third equals 54. Divide by 2. And I get a 27. So what would be our reciprocal of negative 3? Negative 1/3. So if this exponent is negative, your reciprocal also needs to be negative. So again, that negative exponent means it's going to end up being a fraction. So I'm going to start with 1 over. 1/3 means I'm taking the cube root of 27, which is what? 3. So x equals 1/3 is going to be my answer there. Number 3, we got b over 4 times x to the 1/3 equals a to the negative 2. Solve for x in terms of a and b. So first thing I'm going to do is I'm going to fix my a to the negative 2. How can I rewrite that so it's a positive exponent? 1 over a squared. So I'm going to change that first. So now how do I get rid of my b over 4 out front? Multiply by what? 4 over b. So I get x to the 1/3 on my left side now equals 4 over a squared b multiplying fractions, you multiply your top, multiply your bottoms. Our reciprocal of 1/3, 3. So 4 to the third gives us 64. And then remember again, that exponent goes to both of those down below. So that's going to be A6, B3. And there's our answer for x in terms of A and B. So I want you to take a second, try number 4 on your own. Get x by itself, do your reciprocal power, simplify, see how you do. You should end up with 81 as your answer for that one. X equals 81. So we're going to change it up a little bit. This time, my x is in the exponent spot. Any ideas of how we might solve for this? And no, we cannot just divide by 3. So what we need to do is we need to rewrite the 27. Can I rewrite 27 so that it's 3 to an exponent? Yeah, 3 to what power? 3 to the third. So if I rewrite 27, so that's 3 to the third, I now have the same base. I have a base of 3 on the left side, I have a base of 3 on the right side. So the rule is once your bases are the same, your exponents are equal to each other. So x would just equal 3. So let's take a look at the second one. I got a 2 on the left side as my base. My other number is an 8. Can I rewrite the 8 so that it's a 2? 2 to the third. So again, now I have base of 2 on both sides, so my exponents are equal. X plus 1 equals 3. Subtract my 1, and we get that x equals 2. Now for our last one there, we got 10 to the y equals 0.01. 0.01 is very tricky to figure out. How can we rewrite that as a fraction? That would be 1 over 100, which, yes, does turn into 10 to the negative second. Because it was a fraction, that's why it's a negative exponent. And then 10 squared is how we get the 100. So we end up having that y equals a negative 2. So you got to remember, if it's a fraction or a decimal to begin with, it's going to have a negative exponent on there. So our steps. Step 1, get common bases. Like in our first example there, again, we had a base of 3. Second example, we had a base of 2. Third example, we went with a base of 10. So we've got to get a common base. Once you have that, your exponents are equal, so you're going to actually set them equal to each other. And then we solve and check. Common base, exponents equal, solve and check. So for my example to the left there, 2 to the 3x plus 1 equals 16. How can we rewrite 16? 2 to the 4th. So then your exponents are equal. So 3x plus 1 equals 4. Solve for x. What do we get? X equals 1. So again, you kind of want to do some mental checks here. We plug in a 1. 3 times 1 gives me 3, plus 1 gives me 4. So yes, 2 to the 4th is 16. It does work out. So looking at my next example down there, I got 3 to the 3x minus 1, 9 to the x. I got to get a common base, so how can I rewrite 9? 3 to the second. Now what happens here, 9 does turn into 3 to the second, but it's still got that other exponent on there of x. That was on the 9, so when I rewrite it, it's still there. So then we have to do our power to a power rule, so that makes it turn into 3 to the 2x. The other side didn't change at all, so that's still to the 3 to the 3x minus 1. So now our exponents are equal. So go ahead, finish solving for x. Subtract my 3x over, divide by negative 1, and we get x equals 1. So my second example there, I got a base of 16 and a base of 4. How can I rewrite 16? Well, it would be 4 squared. And then it still has that exponent of x squared minus 4x. That didn't go anywhere, it's still there. So then we can multiply our exponents on that 4 over on the left. That gives me 2x squared minus 8x equals my negative 8. Kind of doing 2 steps in one, using my power to a power rule and setting my exponents equal to each other. Because we have an x squared, what are we eventually going to have to do? Factor. So add your 8 over. Divide by 2 to help us try to solve. And how would this factor? X squared minus 4x plus 4. X minus 2x minus 2. So we get positive 2 as our answer. So our third example there, we have a 4 and a 32. Can I write 4 to some exponent to give me a 32? No, that's not going to happen. So I could use a base of 2 though, because 2 to what power is 4? 2 to the second. 2 to what power is 32? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so to the 5th power. So because this is a fraction though, that's going to become 2 to the negative 2. My 1/4 is 2 to the negative 2, and then to the x power. 32 is going to be 2 to the 5th. And then the 1 minus x, that was already part of the exponent there. So again, I'm going to multiply my exponents and set them equal to each other. So negative 2x equals 5 minus 5x. I'm going to add my 5x over, divide by 3, and we end up with 5/3. Always the fraction. Try to avoid the decimal. All right, last one, number 4. What base could we use? Base of 3. 3 to what power is 27? Well, it would be negative 3 because it is a fraction, yep. So 3 to the negative 3 to the 2x. 9 is going to be 3 squared. And then to the x minus 4. So again, power to power rule, so negative 6x equals 2x minus 8. So solving for x, subtract my 2x over, divide by negative 8, and we get a 1 again.